Hey, this is WY6Y, Whiskey Yankee 6 Yankee. This is Steven, and I am sitting in the WY6Y treehouse right now. Recently finished, and yeah, it's kind of more of a tree perch, but I had a bunch of old, well, it wasn't old, it was Western red cedar lumber laying around for a couple of years that my parents used to build their pergola, and then they had a bunch of scraps left over, and I told the builder, I said, bring it on over here. And it sat in a corner of my yard for, oh, 2 or 3 years. And I finally decided what I was going to do with it. So I built this nice little tree perch, not that high off the ground, especially in the back. It's only about 10 feet up, but it gives me a nice view of the woods here. And it's a nice place to hang out. It'll be nice when it gets really hot because it stays a lot cooler down here. So, uh, I'm just embracing it today. And I got the Xiegu G90 out here. Got it set up, and also got a new antenna that I'm using today. Um, I've been building this for about 4 or 5 months. Not that it took that long to build. I just got sidetracked. But I have a new. It's a 36-inch mag loop antenna, magnetic loop, and I've never used one of these before until just today, and it's interesting. I don't really need one. I have plenty of antennas around here. I've got dipoles, I've got verticals. I didn't really need one. I just wanted to tinker with one. I need something to tinker with. I've got to have something to play with, and I've got to have something to do. So I got this mag loop antenna built. It's made from it's let's see. It's actually an octagon. So it's 8 pieces of 14-inch segments of 3/4 inch um, M class copper tubing, and then I used little elbows to make the connections in between the pieces, and soldered those together. I'd never cut copper before, and I'd never soldered copper before. I'm a woodworker. I know all about doing that kind of stuff, but I'd never worked with copper before. It was fun. I really enjoyed it. It was easy. It was not hard at all. In fact, if you're intimidated by the idea of cutting copper, you shouldn't be. It's super simple. All you need is this tool right here. This is a copper cutter. And I found this in my grandfather's old tools. And all you do is slip the copper in there. And then there's a little cutting wheel right here. You put it down in there and get it tight, get it snug. And then you just go around it a couple times and it scores it. You can see the little score line it's making there. And then maybe tighten it another turn and keep going. Maybe one more turn there. And there you go. You got a nice clean cut. And from there, you take a little brush. There's a brush that goes along the outside and a brush that goes on the inside. And you clean that up real good. And then you put some flux all around it, and then get you a nice hot torch, and you're going to solder the pieces from underneath. And you put the torch down there, put your solder where you want it to go, put the solder down there too, and once it gets hot, that flux is just going to suck that solder right up in there, and man, it works. It's super simple. So nothing to be intimidated by there. Using flux and torch and solder and copper cutter. It's really easy, actually. I used a vice clamp. I can't remember what they call it. It's an old Craftsman. It's like a workbench with a built-in vise to hold it as I soldered it together. And yeah, but I mean, it went pretty fast. I got it done, in the morning. So my idea is well, let me stop. Finding the air capacitor is the tricky thing. And when I first started this project, I was looking at all the different types of air capacitors I could use. You can use what's called a book capacitor where you build one your own. You have basically two plates of metal and a hinge in between them. And I thought about doing that. And then I looked at vacuum tube capacitors. Man, those are expensive, hard to find. And then finally, I decided on using an air variable capacitor. I ordered one off of eBay, and I didn't want to spend too much money on this project, so I ordered this one off of eBay. I can't remember how much I paid for it, but it was small. And come to find out, it would barely even handle 20 watts. And since I'm running with the Xiegu G90, uh, 20 watts is what I want to use. So 20 watts max. So I sat on that for a while, and one of my ideas is that I'm going to. I've already started working on this. I built a SWR bridge, Manhattan style of copper, and I've got a couple of coils wound on there so that I can measure the SWR and then have that signal sent two places. The SWR, the voltage, will go to a Raspberry Pi, and one of those little Raspberry Pi 2 watts, those little tiny computers. And what that'll do is it will turn a stepper motor, and that will turn the air capacitor. So that's my idea. That's where I'm going with this. It's I, all the components are essentially done. It's a question of mounting things now, and how to get that right. The way I've got this, the uh, the thing set up today, the loop set up today, is very temporary basis. But eventually, I want to get it so I can leave this set up all the time, get everything waterproofed and whatnot. So you got to decide on your capacitor. Well, last week we had a silent key in our community, and they had an estate sale for him, and I went to the sale, and they had some pretty hefty air variable capacitors there, and I picked up two, and these can handle quite a bit more power than the little one that I initially had. So I decided to finish the project. Also, when I first started this, at the top of the loop, you've got a gap. And what I'm using to make that gap stay is it's a piece of, uh, what's it called? Plexiglass that I've glued together. That's kind of my center insulator between those two pieces. So they sit about that far apart. And so uh, initially, I had used number 6 copper wire coming out near the ends there, going to the air capacitor. And I started talking to a guy online, and he was like, well, you're going to lose a lot of power right there because of the resistance from that copper wire. He goes, what you really need to use is copper strapping. So I just switched to copper strapping. I cut that copper wire off there, and I got some copper strapping. It's 1 millimeter thick. It's pretty thick stuff, and it's a little bit wider than I would like. It's a little bit over an inch. I mean, it was a little bit hard to move, but I've got it on that air cap now, and we're going to try it out here in just a minute. I haven't transmitted on it yet since I changed it, so we're about to find out, how that's going to work. Also, I kind of melted the center insulator a tad when I was trying to put that copper strapping on. Initially, I was trying to solder it in, and then I decided I would go with a mechanical attachment, and I used some screws that go all the way through, and I wrapped the copper tubing around, or the strapping around the tubing. So it's got a very, very good solid connection there. It doesn't look beautiful at the moment, but hey, we kind of do these things as we go. We figure it out, and that's just the way it goes. So I'm about to transmit. Um, I have to say this: tuning tuning is something on a magnetic loop. You get it's a very high Q antenna. So, well, as I was editing this video together, I thought I might stop and kind of explain what I meant by high Q. A high Q antenna stores a lot of energy relative to what it loses or radiates. This gives them a very sharp resonance and narrow bandwidth. Sometimes it's just a few kilohertz. A small magnetic loop behaves like a high Q parallel LC circuit. What is the strength of this? Well, it's excellent efficiency right at resonance. If losses are kept low with fat copper tubing and good connections and a high quality variable cap, which we have here. And it has great noise rejection. They act like a narrow bandpass filter, which helps on receive, especially for rejecting local interference. And strong nulls in the pattern, useful for nulling out noise sources. So those are kind of the pros of having high Q. Now the trade-off is you get that narrow bandwidth. You have to tune all the time. And you get some very high voltages up here. I mean, really high. So you got to make sure that you get that gap maintained right in the middle, because you got some high voltage up there, and man, don't touch it when it's transmitting for sure. And also, your efficiency will drop fast if you use thin wires. So like I said, I had those thin wires right here initially, and I replaced it with that copper strap. So I'm stopping a lot of those losses right there. But I just wanted to take a minute and talk about high Q for a second. So you're getting a very, very narrow dip for SWR. It's very narrow, and you can just barely breathe on that air capacitor, and that dip moves somewhere else. So you have to figure out which frequency you're going to transmit on and get that dip right there. I'm using a nano VNA for tuning it, which that's one problem with an antenna like this is don't plan on doing a whole lot of frequency hopping, because every time you're gonna want to retune, you're gonna have to get up there and change it. You know, that's kind of the idea when I want the Raspberry Pi on there to tune it, and hopefully I'll get that done soon. But yep, that's what I'm working on right now. So I've got it tuned up for 14.273. This is Whiskey Yankee 6 Yankee WY6Y.
Whiskey Yankee 6 Yankee 59, Whiskey Alpha Charlie Lima Radio.
All right, Whiskey Alpha Charlie Lima Radio. This is WY6Y. I'm actually using a new antenna. I just first time transmitting on it. I got a mag loop set up here in the woods. So I appreciate the 5.9. That you sounded great here too in Oklahoma City.
Oh, that mag loop is a great job for you. And you're here at Vancouver, Washington, so it's a good trip. And that's a long way from Sixland.
Yeah, Roger. Well, yeah, I'm just using 20 watts here, so appreciate the 5.9 again. You sound really good. Can I get the call sign one more time?
Whiskey Zulu 8 Tango stroke 7. It's a 7QP contest, so if I don't do the stroke 7, they all get confused. And you're an S9 plus 10 here, actually.
Oh, that's wonderful. I appreciate it. Well, you have a wonderful day in 73 to you. I'm going to disconnect and tune to the next frequency now. So, hey, thanks for coming back, man. Have a great one. 73. This is WY6Y. I'll be clear.
73. Good luck with that loop. Whiskey Zulu 8 Tango stroke 7
Works.
contest.
All the way to Vancouver, 5.9. And he sounds good, too. Sounds really good.
CQ,
So,
7QP, Whiskey Zulu
we know it works.
Tango stroke 7.
Now, this is 20 meters. I designed this thing so that it'll work all the way from 40 meters to 10 meters. Maybe it will even work on 6 meters, but I never do 6 meters. But that air variable capacitor, I've been playing around with it, and I have found a dip on 40 meters, and I've found a dip on 30 meters. I've found a dip on 20 meters. Haven't tried 17 or 15. I've tried 12 and 10. So the good thing about an antenna like this is if you don't have a whole lot of space, you're in a HOA or, you know, an apartment, whatever, you can use something like this and it'll work. As you just saw, it works. So probably not going to be my everyday driver antenna, but I wanted to see if I could get it to work. I think it's going to add a lot to it once I get the Raspberry Pi and the stepper motor on it so it can tune itself essentially. And I I can see a good value in having an antenna like this in your antenna farm quiver. So, and plus, it's just fun to tinker with things and get them to work. You get that aha moment. Hey, it worked! Eureka! You know, great Scott! So I'm glad it worked, and I'm going to try and play around with it some more, and I'm try it on 40 meters later on, and we'll see how it goes. So I wanted to talk about how I told you about how I built the loop, but I wanted to talk about how I got it all on here. Well, let me tell you, ladies and gentlemen, I am zip tie certified. This is a piece of military mast I got from a Army Surplus store in Fort Worth, Omaha. Man, they had a lot of it there. The name of the store is Omaha. The loop, this is the feed loop itself. This is just a piece of number 6 copper I put into a loop, and then I put an SO239 there with a mechanical connection for the ground, and soldered the copper into the center pin. Had to file it down a little bit so it would fit in there, but that worked. Zip ties here, zip ties there. Like I said, I'm zip tie certified. All these connections, you know, they're soldered together. I did want this to look good. So before I was finished with it, I sanded this copper down and polished it so it looked pretty. And then I put a coat of clear protective gloss enamel on it so that it will not rust and you know, tarnish too quickly, because I want it to look nice. Eventually, I'd like to get past zip ties and come up with some kind of a solution here. For the air caps itself, you can't really see it too well because it's, let's see if I can make it a little bit brighter. I used a piece of mahogany I had laying around and just put a little, ooh, that's too much. I put a little bevel right here on the edge so it looks nice, and put a little wood wax on there. And the air caps is connected, it's bolted onto the wood. The wood's zip tied on, you know, nothing fancy there. There's that center insulator I was telling you about that started to melt a little bit. Yeah, be careful there. Next time I build one of these, I won't make that mistake, and you learn as you go. Now I've got the air caps attached there. The strapping, like I said earlier, it's bolted on. That copper strapping is folded over the top, and it goes all the way through, the bolt does. And then I've got the copper strapping going one to one side of the capacitor and then one to the other. So that's just working out. And I've also got this zip tied onto the treehouse today. And I do have a god awful length of coax for this little short operating position. I don't need that much coax, but that was the only coax I had free at the moment. So anyways, it is what it is. So there is another way to put this up. I did put it up a different way the other day in the yard. I 3D printed a ring to go on another piece of this tubing, this mast, and I had it up in the yard with the guy ropes. And this piece of mast here, the bottom piece, has a 3D printed spike, so that can go up in the yard really easily. Got the whole thing up in just a couple minutes. That's another thing that's nice about this. Very easy to deploy. It's up and down really quick. So another thing to consider, ease of deployment. Anyways, that's essentially how it's held together and hanging on there. There's about an, oh, I don't know, inch or two gap there between the feed loop and the actual loop, the big loop. I went with octagonal too, because I wanted it to originally to be round, but this copper does not bend well without collapsing. And after trying to bend a 10-foot piece of it, I learned it doesn't bend well. There's things you can do. You can put sand in it and bend it around some kind of a form, or I think you can heat it up a little bit and do it that way. But I just decided, heck, I'm just gonna make it octagonal and make it look nice. I think it looks pretty nice. for a first rendition of it. So yeah, I'm sure it's not going to be the last one I make, and I'll make the next one a little bit better. All right, so here are my thoughts so far. This would be a nice antenna if you were an activator. It would be a nice antenna if you were constantly on the same frequency. Say you had a net that you wanted to go to a lot. Basically, if you are going to be getting on one frequency and operating there for a while, that would be great because it seems to be working very efficiently. I'm getting great signals with low power over long distances. So if you were going to activate and you had a frequency that you were going to just stick on, or yeah, you got a net that you go on every night, I think it would be great. What it's not great for is hunting, because every time I want to change frequencies, I have to unplug the antenna from the radio, plug it into the nano VNA, retune the cap, and that is a bit of a pain. So that is definitely a limitation at this point without the automatic tuner that I'm working on it. So keep that in mind if you're looking at a mag loop antenna. You have to retune just about every time you change frequencies. And I've heard that that's a good thing because that means that you're getting maximum efficiency on that one frequency. But it's also kind of a pain. But it works. It's a success, and I'm very happy about it. So I'll keep on continuing to improve it from here. Well, I'm WY6Y. This is the mag loop antenna, and I hope you enjoyed the video. Do you need a mag loop? Sure you do. Yeah, build one. They're cheap. I probably built this. It probably cost me, I don't know, maybe $100. You know, that's if you have the capacitor. The capacitor is going to cost you a little bit more, but hey, maybe you'll get lucky like me and you just stumble across one. This will not be my daily driver antenna, but it was fun to build. I think it's going to be a lot more useful when I get the auto tuner guts on there. So stay tuned for that. Subscribe to my channel so you can see when I get that working, because that is in the works. Hopefully I'll have that done in the next couple weeks, and maybe I'll put the whole bit of it up on GitHub so you can download it and make one on your own and enjoy it that way. So anyways, 73, this is WY6Y, and I'll see you next time.